Hello, problem solvers. This is the last section. Your book calls it survival geometry. The old PowerPoints I got from Dr. DeLong called it geometry for dummies. I think maybe we should just call it geometry. We're assuming you know these ideas from geometry back in the day, although if you look at the ice sheet, it is kind of going back and proving a lot of stuff you probably also already know. Um, so points, lines, parallel lines, straight angle, right angle. Probably the one that's hard to remember is interior, exterior angles. I feel free to if you need to check that. Two triangles are congruent if you can move one on top of the other exactly, so all the same angles and all the same lengths. Congruent conditions are side, angle, side, angle, side, angle, side, 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 angle, angle, side, not side, side, angle. Also, not angle, angle, angle. That gives you similar triangles, not necessarily congruent. So like I said here, so similar triangles, these are proportional, so we slightly different notation here. Congruence implies similarity. They have the same shape, but not necessarily the same size. Okay. In a triangle, the sum of two lengths is always strictly greater than the length of the third side, even if the third side is the long one. In a triangle, if one angle is larger than the another, then the opposite side is larger as well. So there's kind of a proportion there. Supplementary means angles add to 180. Complementary add to 90. Supple means big, so that's why. Parallelogram is a quadrilateral with opposite edges parallel, and those are going to have equal length. So notice the markers on the picture. The opposite angles of a parallelogram are equal, and the adjacent angles are supplementary. So add to 180, and the diagonals bisect each other. Some more interesting triangle facts, and those of you that are into college geometry, you can spend a whole semester on triangles pretty much. The midpoints of the sides dissect the original triangle into four congruent triangles. So that's how you make the triforce. You take all the midpoints and then you connect them, and then you end up with four congruent triangles there. Two pieces of advice. In algebra, back when we did algebra and polynomials, you generally want to eliminate and cancel things. Geometry is the opposite. You want to add objects. So drawing a circle around something or drawing an extra edge, that's often helpful. Don't add too many things. And try to think about the penultimate step. Try to work backwards one step from the answer and see if you can get to that. The phantom point method is introducing new points and using givens that you know in your harder existing points. So the idea is that add things that you know should be true, and then don't assume they're true, but use that as a way to get to the thing that you want to be true. Some things about circles. Diameter across the center. Radius would be half of that. A chord is any other line that doesn't go through the center. An arc is just part of the actual circumference, and then a tangent is a line that intersects at exactly one point. Angles and circles. A central angle has a vertex on the center. If you have a vertex in a different part, that's an inscribed angle. Considering the following three statements about a line, a circle, and a chord of a circle, the line passes through the center of the circle, the line passes through the midpoint of the chord, the line is perpendicular to the chord. You should really draw some circles and write this out, but if any two of the statements are true, then all three are true. So I'd encourage you to get some paper out and try to do two of those and verify that the third is true. A tangent to a circle is perpendicular to the radius at the point of tangency, so you should, if you draw the radius and towards that point of tangency, you'll get perpendicular lines. And the perpendicular to a tangent will go through the center. It goes both ways. The inscribed angle theorem, the measure of an arc, so the arc is the pink thing at the bottom, is twice the measure of the angle, the inscribed angle that subtends it. So if you look at the green triangle, or the angle that subtends the arc, right? They took it all the way to the other side, and then you look at the going to the center, you end up with twice that angle, the red part. There are a lot of connections with triangles and circles, a lot of different centers and circles and triangles you can draw with each other. There's always a circle through 3 points. So if you take the 3 points of a triangle, You get a circumcircle, and then there's a point inside the triangle that's the center of that circle. That's called the circumcenter. Ugh. The orthocenter of a triangle is where the three altitudes intersect, and that's going from one side directly 90 degrees straight across to the other point. And the incenter is where you take the angle bisectors and look at where they intersect, and then that creates an inscribed circle. And its radius, we call it in radius.